We'll look at one more optimization problem here. Uh, so we're building a fence. Our LNG construction is competing for a contract to build a fence. The fence will be no longer than 50 yards. So that sounds like a less than 50 yards. And will consist of narrow boards and wide boards. So we're going to declare some variables. Let x equal narrow and y equal wide. We know that the narrow boards are 6 inches and the wide boards are 8 inches, and the whole thing has to be less than 50 yards. A quick conversion of that 50 yards gets us 1800 inches. So that's going to be less than or equal to 1800 inches. There must be no fewer than 100 wide boards. So y must be greater than or equal to 100. And there must be no more than 80 narrow boards. So x has to be less than or equal to 80. And again, we have a real life problem here. So we're going to presume that we can't cut the boards, which doesn't make sense, but we're going to assume that for the sake of the question. So that means x has to be greater than or equal to 0. X is a whole number. Y has to be greater than or equal to 0. Y is also a whole number. Right? We can't have negative number of boards. We're not turning boards back into trees. So these are kind of our restrictions on our variables. And then we're also told a cost. So at some point we have to figure out maximum and minimum costs to build the fence. So cost will equal, the narrow boards are $3.56 each, and the wide boards are $4.36 each. So that's the equation for our costs. So now we have to graph these three, find some points, plug those points into our cost equation, and find a maximum and a minimum. So, so we're going to call each of these 20. So that's 40, 80, 100, 120. 80, 120, 160, 200. So again, on this side, same idea. So we're told that y is greater than 100. So we find that over here. So y has to be greater than 100. X is less than 80. And then we have to graph this thing. So we have to rearrange that. So we subtract 6x from both sides. We have to get rid of that 8. So we're going to divide both sides by 8. And we're going to get y is less than or equal to 225 minus 6x. So our y-intercept will be 225. That'll be up here. I took a minute, I graphed that inequality right there. Got this line here shaded underneath. So the boundary points are here, 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 here. Full disclosure, I grabbed those from the textbook because they weren't easily identifiable on the graph as it sat. Well, 3 of them were, this one not so much. So we have point 0, 100, point 80, 100, 0, 225, and this point here, which is 80, 165. So we're going to plug each one of those into this function here. This is called our objective function. Don't know if I mentioned that before, but that's the objective function. The function to find the maximum and the minimum values. It's called our objective function. So let's take a look at those values. We'll plug them in. 0, 100 ends up being 436. 80, 100, 0, 225, and 80, 165. We'll need to grab a calculator for that. I will just pause and calculate those. All right, so I punch those numbers into calculator. This is our most expensive fence. So we have 80 of the narrow boards and 165 of the wide boards. This is probably also the longest fence that we can have. Here's our cheapest one, which is also probably the shortest one. We have 100 wide boards, and that's it.